sugar and woody fibre are perhaps formed, but no vegetable fibrine, albumin, or casein. If we intend to produce on a given surface of soil more of these latter matters than the plants can obtain from the atmosphere or receive from the soil of the same surface in its uncultivated and normal state, we must create an artificial atmosphere and add the needed elements to the soil. The nourishment which must be supplied in a given time to different plants in order to admit a free and unimpeded growth is very unequal. On pure sand, on calcareous soil, on naked rocks, only a few genera of plants prosper, and these are, for the most part, perennial plants. They require for their slow growth only such minute quantities of mineral substances as the soil can furnish, which may be totally barren for other species. Annual, and especially summer plants, grow and attain their perfection in a comparatively short time. They therefore do not prosper on a soil which is poor in those mineral substances necessary to their development. To attain a maximum in height in the short period of their existence, the nourishment contained in the atmosphere is not sufficient. If the end of cultivation is to be obtained, we must create in the soil an artificial atmosphere of carbonic acid and ammonia, and this surplus of nourishment, which the leaves cannot appropriate from the air, must be taken up by the corresponding organs, i.e. the roots, from the soil. But the ammonia, together with the carbonic acid, are alone insufficient to become part of a plant destined to the nourishment of animals. In the absence of the alkalis, the phosphates and other earthy salts, no vegetable fibrine, no vegetable casein can be formed. The phosphoric acid of the phosphate of lime, indispensable to the cerealia and other vegetables in the formation of their seeds, is separated as an excrement in great quantities by the rind and barks of ligneous plants. How different are the evergreen plants, the cacti, the mosses, the ferns, and the pines, from our annual grasses, the cerealia and leguminous vegetables. The former, at every time of the day during winter and summer, obtain carbon through their leaves by absorbing carbonic acid, which is not furnished by the barren soil on which they grow. Water is also absorbed and retained by their coriaceous or fleshy leaves with great force. They lose very little by evaporation compared with other plants. On the other hand, how very small is the quantity of mineral substances which they withdraw from the soil during their almost constant growth in a year, in comparison with the quantity which one crop of wheat of an equal weight receives in 3 months. It is by means of moisture that plants receive the necessary alkalis and salts from the soil. In dry summers a phenomenon is observed which, when the importance of mineral elements to the life of a plant was unknown, could not be explained. The leaves of plants, first developed and perfected, and therefore nearer the surface of the soil, shrivel up and become yellow, lose their vitality, and fall off, while the plant is in an active state of growth, without any visible cause. This phenomenon is not seen in moist years, nor in evergreen plants, and but rarely in plants which have long and deep roots, nor is it seen in perennials in autumn and winter. The cause of this premature decay is now obvious. The perfectly developed leaves absorb continually carbonic acid and ammonia from the atmosphere, which are converted into elements of new leaves, buds, and shoots. But this metamorphosis cannot be effected without the aid of the alkalis and other mineral substances. If the soil is moist, the latter are continually supplied to an adequate amount, and the plant retains its lively green colour. But if this supply ceases from a want of moisture to dissolve mineral elements, a separation takes place in the plant itself. The mineral constituents of the juice are withdrawn from the leaves already formed, and are used for the formation of the young shoots, and as soon as the seeds are developed, the vitality of the leaves completely ceases. These withered leaves contain only minute traces of soluble salts, while the buds and shoots are very rich in them. On the other hand, it has been observed that where a soil is too highly impregnated with soluble saline materials, these are separated upon the surface of the leaves. This happens to culinary vegetables especially, whose leaves become covered in a white crust. In consequence of these exudations, the plant sickens, its organic activity decreases, its growth is disturbed, and if this state continues long, the plant dies. This is most frequently seen in foliaceous plants, the large surface of which evaporate considerable quantities of water. Carrots, pumpkins, peas, etc., are frequently thus diseased, when, after dry weather, the plant being near its full growth, the soil is moistened by short showers, followed again by dry weather. The rapid evaporation carries off the water absorbed by the root, and this leaves the salt in the plant in a far greater quantity than it can assimilate. These salts effloresce upon the surface of the leaves, and if they are herbaceous and juicy, produce an effect upon them as if they had been watered with a solution containing a greater quantity of salts than their organism can bear. Of two plants of the same species, this disease befalls that which is nearest its perfection. If one should have been planted later, or be more backwards in its development, the same external cause which destroys the one will contribute to the growth of the other. End of section 11.